All right, these are the answers to the study guide, chapter 4, and how to solve them. So use this to help you figure out how to make corrections on your test, since the test and the study guide are so similar. First one here, she's running a race, and her mom is very proud of her and offers her 4 cupcakes for every 3 laps. This one is actually harder than the one on your test, and most of you got this one correct on the test. So you get 4 cupcakes for every 3 laps, okay? And it says she's going to run 24 total laps. So, again, I'd be thinking, well, I have 3 laps, and she's going to run 24 total, so I take 3 and times it by 8 to get 24. So I should be doing the same to this side and get 32. So this one here should be 32 cupcakes. And I know yours on your test is dealing with money and A's, and so that one is actually easier than this one because it's for every A and not for every 3 A's. Next one, Perky the Frog. You have to write an expression. Remember, an expression must have variables in it. X, Y, Z, something. A, B, doesn't matter what the variable is. In this case, he does 3 somersaults. So I know he does 3. I do not know how big these somersaults are. So I'm going to call the somersaults S. S for somersault. Okay? Then it says he does 1 slide 8 feet to the right. To the right I know is plus, so plus 8. Then he does 5 hops, each 4 feet long. Again, to the right. So I can go 5 plus 5 times 4, or I could combine this to make 20. All right, so you could have 3s plus 8 plus 20. You could have 3s plus 28, because you could add the 8 and the 20 together. Right? But you must have those variables. You cannot just have 3 plus 28, because you don't know how big those somersaults are yet. So that's why it is 3s. Okay, and I know yours on your test has 2 variables, because there are 2 unknowns. I believe there's 2 different types of jumps the frog is making that you don't know what they are, so you need 2 different variables, such as an x and a y. All right. Next one. A lot of people did well on the large triangle or the large rectangle on your test. It was the second, the small one that stuck with you. All right. And actually on your test here, you have the same ratio of 300%. Oops, that's 300. Okay. First thing I said, remember in class, look how big the sides are. This side is 4. This side is 3. So my new triangle, 300% is the same as 3 times bigger. Okay. 200% would be 2 times bigger. 400%, 4 times bigger. So since this is 3 times bigger, I would take each of these sides and multiply it by 3. So 3 times 3 is 9, and then 4 times 3 is 12. So the new triangle would be 12 for the height and 9 for the base. You must do it to both sides. Okay? And the big one wasn't the issue, is getting it smaller. Now here we have 50% on the test, you had 1/4. And I'll talk about that in a second. But since it's half, I know half means splitting it in 2 equal pieces, cutting it in half. So I should do 3 divided by 2 is 1 1/2. And then 4 divided by 2 is 2. So I have 2 for the height now and 1 1/2 for the base. Yours was 1/4. 1/4 is the exact same thing as dividing everything by 4. So you must divide both sides by 4. And I know your rectangle on the test was a 2 by 3. You must take both of these numbers here and divide them by 4 to see how big your shape will be. And your shape will be very small. It won't even be a full square. All right? Next one, the ratio one. A lot of you just wanted to do on the test 8 times 4 is 32, and you said it works. It doesn't work like that. Remember, we talked about in class how this is asking the ratio A to B has to be the same as B to C. Has to be. Okay, it's not saying I'm going to take A and times it by B to get C. That's not what the heck it's talking about. It's talking about, okay, it's talking that the ratios must be the same. So I know A is 4. And then the problem it said could be 9. Okay, that has to be the exact same thing as 9 to 36. All I did was plug the numbers in here with the letter where they belong. Now I got to see if these two ratios actually are the same thing or not. One way to think about that is this. 9 times what is 36? Well, I know that that should be 4. And if I do the same to this side, I don't get 9. I would get 16. So that tells me right there that 9 is not the correct answer. Another way to prove this would be to make these both into unit rates. So get them both down to 1. So in my example here, if I make this to 1, if I divide this side by 9, and sorry, it's getting squeezed in there, I have to do the same to that side. 36 divided by 9 is 4. So if I do the same to this side, I can't divide by 9. I have to divide by 4 this time. 4 divided by 4 is 1. 9 divided by 4 is obviously 2.5. These here are not the same. They must be the same in order for that number to work for B. And on your test, you had a number, and a lot of you thought it just worked because 32 divided by 4 was 8. It doesn't work like that. You need to prove it by using these ratios, such as these ones on the board. Ooh, bless me. Okay, next one, and last one actually, was dealing with the frog again, and this is very similar to the problem you had, except you had 2 variables in it. So, starting off, it says Tad does 8 super double jumps. We don't know how big those are, so we have to use a variable. So it's 8 times, in this case here, it tells us to use x. 8 times x, and super double jump is x. Okay, and we do 8 times x, okay, because it's 8 times however big each of those jumps are. Then it says he moonwalks backwards 2 feet. Backwards means you're subtracting, you're getting negative. So you're going to subtract those 2 feet. Okay, now I know on your test question, one said backwards, one said forward. Obviously forward should be adding because you're going to the right, and subtraction will be going to the left. Right? And the last part of this problem is it tells you they went 70 feet. Okay, there's your expression. And the one on the test, I didn't tell you how far they went in the first problem. It was getting down to that second problem where you had to plug that in and solve for that. Okay, now you have this problem here, and you need to figure out what x is. Okay, you should be thinking in your head, what does this part of the equation have to be? What does that 8x have to be in order to subtract 2 and get 70? Well, like we talked about in class, in our heads, we should know that that has to be 72, because 72 minus 2 is 70. So if 8x has to be 72, that means 8 times something is 72. 8 times something, that something must be 9. So x has to be 9 in this case. Okay? I just want to go to the test real quick and show you one thing on there, on that last problem. Oops. And that is this. Okay? Dealing with the frog. Right? You needed 2 variables. Okay? You have one for the cartwheels, because it doesn't tell you how big it is. Then it tells you, then you have the handsprings. Okay? That's another variable. And remember, I told you in class that these 8 backward slides are each 1 foot. Okay? So you don't need a variable for that one because you know how big each of those slides are. Okay? So again, you should have something with the cartwheels, something with the handsprings, and then obviously the 8 backwards ones. That's kind of your general form to set that problem up. In A here, okay, it says they ended up at 6. When it says they ended up at 6, that means your whole equation for this part, your whole equation here has to equal 6. Excuse me, I almost wrote a 2. Has to equal 6, because that's where he ended up. Okay? And then you'll notice here I tell you how big the handsprings are. 5 feet. You should plug that into your variable for your handsprings. In this case, I used h. You didn't have to. But I should be taking that 5 feet and plugging it in for h. And then the only thing you need to solve for is c. Okay? So make sure you make those corrections on your test and bring them to me when we do the retest here early or end of next week. Have a good one.